Right, so if we look at the book, I'm taking it from the book again. As you will see in the rest of this chapter 3, many situations in the world around us can be modelled by linear functions, okay, straight line graphs. Now the average rate of change for a linear function determines the steepness of the line and is called the slope of the line, okay, the average rate of change for a linear function. Now we can do average rate of change on a lot of things. I mean, look at this over here. This is not a linear function if the dots are going all over the place. I can make a straight line in between it to do the approximate average rate of change, okay, so if I knew what that figure was right here, okay, and I knew what that was down there, then I can see, again, it's like the weight loss one. How much have we gone down over, say, 5 weeks, okay? But it's not really a linear function, although I can still do the average rate of change, okay? What was it over those 5 weeks? How much weight did I lose? What's my weight loss per week? Now, a linear function, so straight line graph. Now, let's have a look at this, okay? It is the change in the y's over the change in the x's, okay? And we've been doing that. I mean, you know, if I do the slope of this line, or rather the average rate of change, I want to know how much it went down, okay? That's the y direction. In, say, how many weeks, if I'm doing weight loss, okay? You know, if my weight goes down in so many weeks, what's my average rate of change? What's my weight loss per week? Okay? So it is, think about it, this change in y over the change in x. That's the average rate of change, it's the slope. Now look, you might see something here, just a little bit here. This is just called delta notation. It just means the change in, okay? The change in y over the change in x. It's just some way of shorthand writing, okay, what is the change in the y? What is the change in the x? Okay? That's just called delta notation. So, let's have a look at an example. Now, in the book, this too is a negative, and I'll come back and do it later. Let's make the kind of numbers nice for now. So what is the slope between these 2 points? Okay, it's like saying, okay, what's the average rate of change, but what's the slope between these 2 points? Okay, now can you see over here? This would be a negative slope because it's going down, but let's have a look at this one. I've done a little graph. Okay, 1, 2, x and y, and 3, 8, x and y. Here we go. So here is 1, 2, right? Here is the point. Let's get a little bit of a smaller pen. Okay, this is the point 1, 2. And this is the point 3, 8. Now if we just look at this on the graph paper, can you see it's gone up? It's gone up by 6. The change in y's was 6. The change in x's was 2. The slope is 6 divided by 2. The slope is 3. Okay, that's it. That's the slope of that line. So let's have a look at, and you know, if I go down here a little bit, it might not be on this particular page. Now let's go back and do this then. I'm going to put a minus here, right? Because that's what it is in the book. Okay, so I'm still going to do the same kind of thing. Okay, now what we're going to do here is we're going to use this little formula. All right, see that there? This is an important formula. Now, what I've got down here is the kind of instructions. If you want to, you can call this here the first set of x, y coordinates, okay? If you're going to call that first set, little subscript, we'll call it x1, y1, okay? So, we're going to call this here, let's just erase that line so I can kind of write underneath it. We'll call this the second set, so this is x2, and the 8 is y2, okay? X, y coordinates. And it's nicely written right here. Let x1 be 1 and y1 be -2. That's that coordinate here. And let x2 be 3 and y2 be 8. That's that there. Now once you just label those, here's x1 and y1. Here's x2 and y2. Just put the numbers in the correct place. Look, right here. Right, y2. What's y2? Let's have a look. It's 8. Right, 8. Take away. Right, what's y1? Now be careful. Here's where the problem's going to be careful. I'm taking away -2. Now watch that, okay? It's nice to write it like that. Okay? Even if I put them both in parentheses. There's the 8, the y2. I'm taking away a y1, which is -2. Okay, that's going to be plus, isn't it? Double negative. Watch it. Now what's my x2? Where's x2? Where is it? It's 3. Make sure you put them in the right place. Take away. Right, what's my x1? It's 1. Okay, there we go. So what is 8 negative negative 2? That's positive. Well, isn't this going to be just 10 on the top for the difference in the y's and 2 for the difference in the x's? The slope is 5. That's the answer. The slope between those 2 points is 5. Do watch your double negatives. Remember, it's always a minus there. If the coordinates are also minus, you might have some double negatives. Okay, that's it.